everyone. I'm Jen. I'm a senior front-end engineer at a company called ClassPass. Raise your hand if you use us. Woo, mostly women. And if you want to reach out to me on Twitter, my handle is girlcode. I'll also be posting the slides to this talk there afterwards. So the title of this talk is React 16, the Future, and You. But I've been thinking a really good alternative title for this is Dear React Core Team, I love you, but please stop releasing new features long enough for me to give this talk. So I've actually given a version of this talk before back in April. I had to update it a lot because obviously a lot of things are happening in React. There's been new features released, and a lot of upcoming features have been talked about by the React Core team. And it's just been a whirlwind. And if you're really familiar with the new proposal that was launched at ReactConf, I'm just going to tell you up front, no, I will not be talking about hooks today. Hooks are still unreleased, and I only have so much time, so, priorities. So what I am going to cover is React 16.0. And at this point, you might be thinking, what? It has been over a year since this was released. We are well past that. But the truth is, we really aren't. We're still only in the early stages of all that the React Core team has been focusing on for years. And to understand that, we're going to need to go back to the beginning. So you might be thinking, I'm thinking, why the fiber? So React 16.0 introduced fiber. And fiber is what makes everything that we're seeing now possible. So let's remind ourselves why it's important. Fiber is React's new reconciler. And its job is the same as the old reconciler, to determine what parts of your application have changed and to update your application. So before version 16.0, reconciliation happened recursively. The reconciler would call the render function and other lifecycle methods down the tree to create a snapshot of the application, and then compare that version to the new version, or that old version to the new version. And previously, we didn't have a name for this type of reconciliation, but in order to distinguish between the old and the new, we now refer to this as the stack reconciler. So here we can visualize the stack reconciler in the context of the main thread. So whenever there's an update to the state of your application, the stack reconciler starts its recursive work to reconcile the old state with the new state, and then update the DOM. And what's problematic here is that stack reconciliation isn't interruptible. So if the main thread has other work that it needs to do, it has to wait. This is fiber. So fiber is actually non-blocking. So with fiber, reconciliation is going to happen in small blocks or units of work. And periodically, the fiber reconciler stops its work to ask the main thread if it has any work that it needs to do. And if it does, fiber is going to pause its own work, and then it requests that the main thread let it know when it's free again. If the main thread has nothing to do, fiber is just going to keep on doing its work. And this is, by the way, already really amazing. I kind of forget this fact every once in a while because I'm just doing my own work and not paying attention. And then I remember the work that's been done to make this non-blocking. It's really amazing stuff. It feels really magical. But it's not really magic, obviously. This cooperative scheduling is due to a web API, requestIdleCallback. And that allows you to schedule background tasks when the thread is free. So I'm not going to get into the details of how this works. It's really fascinating. And it's also really interesting to note that currently Fiber is using sort of a polyfill version for this instead of the native implementation. And I'm going to talk about that a little bit later. But everything that we're talking about here with Fiber is what the React Core team recently renamed Concurrent React. So you might have heard of async React. That's now referred to as Concurrent React. So async wasn't quite the right term. What the React core team wanted to showcase was all that the Fiber reconciler makes possible for us. And we've covered the first part of that, which is that it's non-blocking. But Fiber also makes priority possible. That's to say that the updates to your application can now be assigned a priority, and that a higher priority update can jump ahead of a lower priority update. So Fiber reconciliation happens in two phases. So first, there's a render phase where reconciliation occurs. And in this phase, that's where Fiber is going to build up a work in progress tree to determine the list of changes that it needs to make in order to update the UI. But it's not actually going to make any of those changes at this particular stage. That's the responsibility of the commit phase. So this is when the changes in the previous phase are actually committed to the DOM. And you'll notice that reconciliation is the longer running phase here. That's by nature. There's just more to do in that stage. Whereas the commit stage, the actual updating of the DOM, is a much shorter phase. So it makes sense that the longer phase occurs in units of work, because this allows the reconciler to communicate with the main thread and to pause its work. And it also means that the render phase can be interrupted. So each time that the Fiber reconciler asks the main thread if it has work to do, the reconciler needs to pause its own current work. And since the reconciler's work can be paused, this allows for other work to come in and take priority. So Fiber's render cycle is interruptible for this purpose, either for main thread work to yield to the main thread or to yield to a higher priority update. So, for example, the reconciler could be working on a lower priority update, like just updating a list, and a higher priority update, like user input, will come in. So it's going to stop its lower priority work. It's going to work on the higher priority work. And then once that is completed and committed, it's going to go back to the lower priority work. Now, the commit phase is uninterruptible. And that's obviously to prevent there from being inconsistent UI. You don't want to have a bunch of committing users will see flashes of incorrect UI. And what we just talked about here is a feature known as time slicing. So this is one of two marquee features of concurrent React. And we're going to talk about the other one, Suspense, in a little bit. But time slicing brings us to React 16.3, because it's the culprit behind the lifecycle changes released in this version. So even though Fiber shipped in React 16.0, concurrent React is not available yet. Reconciliation at this time is not time sliced. It would be really nice if you could write a completely new reconciler and just plug it in and everything worked as is. But concurrent React is such a different architecture from what we've had before that it requires some extra work. And in particular, the React core team discovered certain lifecycle methods were unsafe. So depending on which phase you're in, different lifecycle methods are going to be called. The problem is that some of the methods in the render phase, like component will mount and component will update, we often use these for side effects, like hooking into the DOM or data fetching. And that means that these lifecycle methods are impure. So because the render phase is interruptible, a component's lifecycle methods might be called more than once or not at all. So if you think about component will mount, we expect that the inverse component will unmount will be called at some point. And the same for component will update and component did update. We expect those to be called sort of in a pair. But since Fiber can pause its work or abort its work based on priority, that actually is no longer true. So Fiber could call component will mount and then abandon that work for a higher priority update, and then never call component will unmount, because that actually happens in the commit phase. And that's just one example of how things could go very wrong in this new concurrent world. So With the big changes in reconciliation, in order to get all the awesome features that's going to provide us in concurrent React, the React core team announced that these lifecycle methods will be deprecated in the future, and new lifecycle methods were released to replace them. If you're using component will mount for state initialization, you're going to put that work now in the constructor, or you're going to use experimental class properties. Component will receive props will be replaced by get derived state from props, and that's a static method on the class. It's invoked right before calling the render method, both on the initial mount and on subsequent updates. And component will update is replaced by get snapshot before update. So it's invoked right before the most recently rendered output is committed. So right before the commit phase, there is a brief pre-commit phase where you can access the DOM, and that's when this is called. Now, I'm not going to get into the specifics of how each of these new lifecycle methods work, but I want to note there is really great documentation for these. The React team has done a wonderful job documenting these, as well as they have an excellent article on simpler alternatives to get derived state from props. And there's a link to that at the end of these slides. So these new lifecycle methods, get derived state from props and get snapshot before update, are really actually meant to be used in rare cases. And that document really goes over, what are some simpler alternatives to this and better architecture for these things. So I do recommend reading up on that. Now, the old lifecycle methods aren't deprecated. You can keep using them today as is, so I hope I didn't panic anyone. 16.3 was a release for libraries to be able to start the migration, but also to let the broader community know that this will be happening at some point. So lifecycle methods, they're not going to be officially deprecated until React 17, so you have a good while. And even then, like after React 17, you can keep using them. You're just going to need to use this unsafe prefix because, these are unsafe. There's even a code mod available to rename all of your methods with the unsafe prefix. And this is a really good first step, so I recommend doing that. I also recommend that you wrap your application or a subtree of it with the strict mode component that was also released in 16.3. So this is a way of opting in to unsafe lifecycle warnings, as well as finding potential issues with side effects in your application. So what strict mode does is that it double invokes parts of your component's lifecycle methods to find these issues. And it's only going to do so in development, so you don't need to worry about this making it to production. But it's a great option for starting to clean up issues or move over lifecycle methods until your application is ready for concurrent React. And of course, if you're starting a project from scratch, go ahead and use strict mode. Go ahead and use the new lifecycle methods. And we have one other issue to talk about this, and that is data fetching. So specifically, if your data fetching and component will mount, you're going to use component did mount. That's the recommendation. Of course, that doesn't work for server-side renders since component did mount doesn't fire on the server. So in that case, you're going to move data fetching to the constructor, which does get called server-side. Of course, data fetching is still a side effect. So doing this work in the constructor is actually temporary until React's solution for data fetching, Suspense, is released. So let's talk about Suspense. It's the other marquee feature of concurrent React. So with Suspense, you can suspend rendering of an application while waiting on asynchronous data in a lower level component. Suspense is very similar to error boundaries. These components will catch and then display a fallback UI. But unlike error boundaries, Suspense is not catching errors, it's catching promises. So a thrown promise will be caught by its nearest Suspense parent. And the fallback UI, which is normally like a spinner or a loader, is going to be shown. So loading states are a really painful problem for both users and engineers. I want you to think about how often you've seen a flash of a loader before data is loaded. And often you don't see one loader, you'll see several flashes of them as the page loads. This is a really poor user experience. Plus, as an engineer, I have to keep evaluating which component has loading state, and I also have to keep calculating that state. Like if I'm building a page that needs venues, reviews, schedules, and like who knows what other data, I need a statement like this. And I'm probably going to do this in a parent component, so I'll also need to provide a prop to children components in order to render the correct state. But Suspense solves these problems. So you can throw a promise in a lower level component, and it will be caught by the closest Suspense component above it. Now, Suspense is made possible by Fiber. Fiber is pausable, so the reconciler can pause until it gets the data back. And you might think, oh, I would really like to go ahead and start migrating this over. I have to wait for concurrent React to do this. You actually don't. So as I mentioned, Fiber came out in 16.0, but its concurrent mode is not available yet. What it's currently using is sync mode. So it's not yielding to the main thread, and there's no priority updates right now. But you can still use Suspense with sync mode. This is great because you can incrementally adopt Suspense without waiting for concurrent mode. That's the upside. The downside is that Suspense won't work the same in sync mode. So, for example, you won't be able to set a max duration in sync mode. So max duration is a prop you can provide the Suspense component, and it acts as a threshold. So it's how long you're willing to wait in milliseconds before React should render the fallback. So if you're having a Suspense component wait for some data for you, if that's taking like an extra long time, so it's going over your threshold, then it'll show the fallback. In other words, it's going to wait. So it's going to wait until it hits that threshold to actually do the reconciling. We'll see why in a second. But you can set it to 0 if you just want it to like immediately render the fallback. And in sync mode, you just lose the capability to set a max duration at all. It's always going to be set to 0, so the fallback UI will always be visible. Because in sync mode, the reconciler doesn't wait for anything. It just synchronously moves through. And this is actually contrary to what Suspense is meant for. So Suspense is not a feature for displaying a loader. Suspense is a feature for avoiding loaders when possible. So on a slow connection, we want to show a loader. Loaders are a really important UX feature. On slow connections, it gives the user a feeling that something is happening, that the user's action initiated something. We don't want to do away with loaders. We lose a really important option for cluing the user in. So on slow connections, Suspense will show the fallback UI. But we want to avoid loaders on fast connections. With Suspense, if the connection is fast enough, we want to avoid flashing a loader. So the user will see the content as if it had already been there, waiting for them. And this is a beautiful, seamless transition. It feels really good. Like to me as a user and to me as an engineer. And that's what Suspense is for. We can avoid loading states on fast connections, but we don't actually want to lose the ability to show a loader on a slower connection. So that's what Suspense is giving us. Now, Suspense as a full feature for data fetching is not available yet, but in React 16.6, they did release one Suspense feature, and that's React.lazy. So React.lazy is Suspense for code splitting. So to use this, you're going to wrap a dynamic import in a call to React.lazy. You'll wrap that lazy loaded component in a Suspense component with a fallback UI. When the component needs to be loaded, React.lazy will load it. Suspense will show the fallback UI in the meantime, if it has to on a slow connection. Once the component is loaded, React.lazy will cache it. So subsequent requests for this component, it will just grab it from the cache. And this is really useful for loading components such as lower resolution images until a higher resolution image is available, or to loading content when the user actually requests it, instead of just in case they might. And you can start using this today. So this is out in 16.6. Just note that this is not available server-side yet. Server-side Suspense is going to be coming in 2019, according to React's recent roadmap release. So the general plan is that hooks are coming in early 2019, or maybe right now as I'm speaking. Concurrent mode will be available in early to mid 2019. And then Suspense for data fetching, not just code splitting, will be released later in 2019. And all of these features, by the way, are opt-in. So you're going to be able to adopt them in a time frame that makes sense for you and your code base. Now, the React core team also has other plans for 2019 and beyond, but these features involve more work, including experimentation. So the scheduler, for example, that's the requestIdleCallback polyfill that I mentioned earlier. So this is a way of handling the priority updates while also yielding to the main thread, and then yielding to different priority updates. And it's not really actually a polyfill. The React team started with the native implementation of requestIdleCallback, but discovered that the native feature just didn't work as well for handling the various priorities. Because it's not just low and high priority, there's other priorities as well, like going ahead and rendering like hidden content in the background, and also animations. So what they did is they built their own scheduler. And this is still a work in progress, but the team is collaborating with the W3C and the Chrome team to move towards an expansion of the native solution. So keep an eye out for that. It's really amazing work. I really love that the work that React is doing will have an actual impact on the browser and how we do work in the future on it. Okay, and then finally, I want to talk about fatigue. And this is not a new feature in React. I know some of you were like, no, I don't know this. It's cool, don't worry. So as I've been talking today, you might have found yourself somewhere on this continuum. Maybe everything I'm saying to you is like really exciting, but maybe it also feels exhausting because there is so much to learn. Like I didn't go over everything that's been released this year because that would take hours. And like I totally get both sides of this. So today I'd say I'm about here. But other days I could really be somewhere else on this line. So if you've been working with React for a really long time, like me, this is the first time you're experiencing truly large-scale changes in React. And if you're learning React now, you're stuck between the old world and the new world, and likely frustrated by the ever-increasing list of new things to learn. Being curious is like really hard. You want to know how things work. You want to know what's coming up next. And satisfying your curiosity can be exhausting. And it's also really hard to learn a thing that's unfinished. Like, you'll learn it, and it's going to change, and then you'll need to update what you learned. So one of the reasons I'm actually not talking about hooks today is I'm actually avoiding fatigue right now. I'm not saying that those of you who do learn the thing, or write about the thing, or talk about the thing, or contribute to the hooks proposal are wrong by any means. We absolutely need people to do those things. But if you feel that your worth is decided by keeping up with React, if you feel a lot of pressure to learn these features and concepts right now to feel accepted in this community, I want you to know that your value is not tied to if you know or how well you know these things in the moment they're released. You have time to learn them, and I trust you will satisfy your curiosity when you can, and that is totally okay. And then finally, I just wanted to note sort of how I work through this, because This is the first time also that I'm dealing with a lot of changes in React and keeping up with them. So you'll notice that during this talk, I talked a lot more about the concepts, and I didn't show really much code at all. So the concepts are what's going to stay constant. So if you focus on learning the concepts and not the code just yet, you'll be able to keep a lot more of this in your mind and then see where you could place it in your code base. So for instance, with hooks, I'm not digging into the code for hooks, but I have a good general understanding of the concept of hooks. And as I move through my code base, I can kind of see like, oh, here's a good place that when I'm finally ready, I'm going to try out hooks. And the same for a lot of the other features that are going to be coming out in React. So this is how I deal with it. As Josh mentioned earlier, we're all different learners, but that's my piece of advice. And with that, thank you.